Yes, friends, today we're starting the Kafka training. We'll talk about Kafka's architecture. How does it work? What is its system like? Besides that, why should we use Kafka and where should we position it? We'll discuss those topics. Afterwards, we'll look at Kafka's installation and configurations. We'll see how to integrate it with Spring and wrap up with an example. First, we need to talk a bit about Kafka. What is Kafka and why do we use it? Actually, in our trainings, we've mostly done these kinds of operations with RabbitMQ, but if you're going to handle large-scale and intensive tasks in the industry, especially when writing event-driven applications for big corporate companies, it really makes much more sense to use Kafka here. Use Kafka. There really are some huge companies out there. I tried to list a few of them. Here, companies that stand out to you like Netflix, PayPal, Adobe, Airbnb, they use Adobe. They use Kafka. So, what is this? What does Apache Kafka do? Here's the idea, friends. We have an application. When users make requests in our application, a lot of things can happen in the background. Think of it this way. Someone makes a booking on Airbnb at any company. When the booking is made, there is a single service that handles it. That service processes the booking. So, you send a request to an endpoint, but there are many processes that need to happen in the background. For example, the payment process for the booking is a separate matter. There are a lot of things, like updating the person's account with that information, sending an SMS or email after the booking is made, or notifying the owner of the house or whatever is being rented with an SMS. These are all things that need to happen in the background. Kafka is what actually makes this possible. Normally, when a request comes in, you send it to a single endpoint, but in the background, there are a lot of other microservices that need to be coordinated. Now, if you try to send requests to each of these microservices one by one and wait for their responses, the user will end up waiting the maximum amount of time. So, what am I talking about here? Now, let's say you clicked the buy button, everything's done. The purchase process is about to be completed. Here's how the system works. A request is sent to the central purchase endpoint. That endpoint then asks service A, B, C, D, E, F, 10 services. It needs a response from all of them. Why? So it can get back to you. Everything's fine. To do this, it needs to get a response from all the services. You can do this directly with the client. Yes, it asks each one individually, does it peer-to-peer? But the problem is, until it gets a response from all of them and gets back to you, it might take 10 seconds, a minute, or maybe one of them will get stuck. The moment you send a request, a lot of things can happen, a lot of problems can arise. Now, this is something we don't want. What should normally happen, if I'm the purchasing service, I carry out the purchase operation and finish it. Then I tell the other services, guys, I've done my part, I'm finished. You do your part too. In order for you to be able to do this, you need to have a queue system. Apache Kafka actually provides this. The service that performs the operation finishes its job and sends a message to a queue related to it. It says, hey, I've finished my job, whoever wants to do something, go ahead and do it. Here, we see that Kafka's queue system is being used, friends. So, how does Kafka work now? Let's take a look at that as well. Kafka has a somewhat complicated system. Now, the internal structure of Kafka, or rather the Kafka cluster, is as follows. Inside it, there are internal servers called brokers. These servers, friends, are small servers that are integrated with each other and can work in parallel. You can think of them like this. Imagine a computer that stores your data. As you enter data, imagine that it gets written into this computer. But over time, as your workload increases, imagine that this computer is no longer sufficient. What do you have to do? You need another computer. This way, the data can be written to this new one as well. More computers, more and more. So, think of these as computers that can both share the workload and increase capacity, speed, and reliability. These are called brokers, friends. Within the Kafka cluster, the structure formed by the combination of these brokers is called the Kafka cluster. Of course, this part is a bit more detailed, but we don't need to go into too much detail. Now, for these computers within the Kafka cluster to be aware of each other, to be organized, and for new brokers to be included in and detected by the system, this system needs to be managed, friends. So, this system can't just run however it wants. So what happens then? I mean, who is going to handle this management process? Well, this management process, the organization and security of the brokers within this cluster, or if any of them drops out. Let's say, for example, broker number 5 goes down, it's gone for some reason. Oh, in that case, the data here needs to be recovered. It needs to be organized. But the system needs to keep running uninterrupted, even if a broker goes down. So, the component that organizes all this is Apache's Zookeeper, folks. There's an important point to pay attention to here. Zookeeper is no longer supported in newer versions of Apache clusters. I mean, it's still supported for now, but it will be deprecated in the future. You can still use Apache Zookeeper for a while longer. But gradually, we've gotten rid of Zookeeper within the Kafka cluster thanks to a new structure called Craft. What does Craft do? Craft is a component that exists within the Apache Kafka cluster, so it's not something you need to add from the outside. This way, the Kafka cluster becomes more lightweight without Zookeeper, folks. We'll also see this in our training sessions. I'll show you the differences between Zookeeper and Craft, and also how to integrate and set up with Craft. That's the basic idea here, folks. The brokers inside this Kafka cluster need to be organized somehow. You can do this either with Zookeeper, which is used in older projects, or with Craft, which is used in newer ones, folks. Within the Kafka cluster, the data it receives, or more precisely, the data received by the brokers is indeed placed using a queue system, but with a key difference. Now, we had a structure called RabbitMQ. What did RabbitMQ do? It also provided a queue system, one of the features that distinguishes RabbitMQ from a Kafka cluster. In RabbitMQ, incoming messages are cached, kept in memory, and deleted after being read. In a Kafka cluster, the data is stored in storage. When the data is read, it is not deleted, it remains. If you want to set it up differently, you can also perform deletion. In other words, you can remove it from the queue. We will see these. Now, let's see what's inside a broker. What kind of process happens in the broker, friends? There are two sides, one that sends data to the broker and one that reads data from the broker. One of these is the producer, and the other is the consumer, friends. The producer sends the information it needs to the Kafka broker by making a request, friends. Maybe I have such information. Take this information. The broker receives this information. It processes this information. It puts it in a certain order and writes it to disk, friends. So, what does the consumer do? The consumer listens to any queue system, of course. There are many different structures here, which we'll see later on. We have the concept of a topic. We'll see that in more detail there. The consumer starts listening to something. It starts listening to a topic. When a message arrives there, it takes the message from that topic and processes it, friends. The logic I just mentioned, when you rent a room, the service handling the room rental does its own job. After it's done, it sends a topic to the Kafka broker, saying, I've completed the rental, now you do your part. Other microservices that are listening to this topic take the information that lands there when something is posted, and they handle the tasks that fall under their responsibility, friends. Now, when we come to the topic part, these topics here are the information you have passed along. So, as I just mentioned, I completed the sales transaction. For example, I sent the topic. After sending this topic, it is stored within the Kafka cluster, friends. This information is stored, but in order for this information to be secure and high-performing, it is stored in a different structure. These topics are divided into sections called partitions. Think of it like this. Let's say we have 5 brokers. Imagine that my topic is split into 5 parts and added to these 5 brokers. It could be more. So, there could be more parts, or fewer. This is entirely up to you. I said, split this into 5 parts or into 50 parts, 10 for each of them. Why am I doing this? Because splitting a whole into 5 and giving it to these 5 brokers, that is, giving it to 5 different computers and then reading from them, increases both the write performance and the read performance. In the same way, partitions are divided into segments, and you need to write these. So, think of it like this. Each partition has a certain segment, and they are written in this way. Again, This is a very important point in terms of data loss prevention and data accessibility, friends. That's why using both partitions and segments here increases Kafka's performance and security, friends. So, let's try to understand the segment part a bit more. Let's try to get a better grasp of the topic segment concept. Now, inside our Kafka cluster, we have brokers like this. As I mentioned, think of these brokers as our servers. As you can see here, you have topics, in other words, your tasks. For example, I sent a task, task A, the green task. So, what have I done with this? Look, I've split it into partitions and sent it to different servers, guys. In the same way, the data I've sent, for example, in this broker, there are two partitions inside two brokers. What have I done in this partition? I've divided it into segments. Why am I doing this? We do this so that read and write operations are a bit faster and more secure. We manage our structures this way to make them more secure, guys. Of course, this alone doesn't guarantee our security, guys. There are other structures as well. For example, let's say we have a topic like this. In our topic, there are partitions 0, 1, and 2. Let's say broker 1 crashed. Now, the moment broker 1 crashes, all the parts of all topics will be missing to some extent. So what happens then? Well, tough luck. But actually, that's not the case. The logic here is that brokers divide their internal data into partitions and replicas. So, the replicas of the partitions inside broker 0 are actually on broker 1 and broker 2, guys. So even if this one crashes, the others can keep going. In other words, this system works redundantly. So, how does a value we send actually work? I mean, we sent a value, we sent a topic. How is this topic information recorded? Now, this system, this structure, is our Kafka stream, guys. When you send a topic, it gets queued up, guys. Did you send another one? Another one? 1, 1, 1. It keeps going like this. You keep adding more. These are your events, in other words, your topics. So, when a new event is added, where does this event get added? Look, the events that happened here before, whether I send them, meaning the producer sends them, or the consumer reads them, it doesn't matter at all. All the topics here remain, guys. And when there's a new event, you just add the new one right alongside. So when I send a new topic, when I send a new record, it gets added to that queue. In other words, it keeps going by being added to the queue, guys. Alright, so that's the logic here. You, the producer, send a new record, and the consumer listens here. When a new one is added, it reads it. So, how does each event we see here actually look? So let's say I sent an event, like to topic A for example. I sent information to topic A saying that I sold the product. What does the inside of this look like? Look, now, the data you see here, the data you sent, the data you wrote to that topic looks like this, guys. Usually, the data we send includes a key and a value, guys. We send these two, but besides these, there are two more parts. One is the header, which you can specify if you want, and the other is the timestamp. This timestamp is added here when the topic is delivered to the other side, even if you don't do anything, so when you send the data, a timestamp is given here. If you want, you can also send this yourself. In other words, you can say, don't interfere, I have my own event order, and I'll send it along with the timestamp according to that order. In that case, the addition will be done accordingly, friends. Another topic we have is replication. So, what is this? I mentioned it above just a moment ago. Let's say I have a partition. I've divided my partition, right? So, I've put partition 0 on broker 0, 1, 3, on all of them. In other words, I've distributed them to boost my performance. But what happens if broker 1 crashes? A part of my partition is gone, some of my data is lost, it's disappeared. That's not the right thing to happen. So, what am I going to do then? I'm going to back up this partition to the other brokers as well. In other words, we're going to do replication. Partition 0, 1, 2. These are the replicas, the copies. So, what happens this way? What will happen if this one crashes, or that one crashes? Since the data here is sent to each other, and the main data is also sent to the others, what will happen? It will continue with backups, guys. When one crashes, the other replica will actually become the primary. This way, it will be able to continue smoothly without any issues. Guys, basically, this is the structure of Kafka. This is the general structure that operates and exists inside. Guys,